Good morning, good afternoon, good evening, whatever it is, wherever you are. I'm going to do a little video today. It won't be as long as my last one. I'm going to do a little bit of video today on lime and cement. Both are used a lot. Cement nowadays is used in virtually every building built. And once upon a time when there was no cement, lime was used in every building ever built. Never the twain shall meet, but we'll come to that in a bit. So a little bit of history. Lime has been used as a binder for thousands of years. But Portland cement, as we know it today, was invented in 1824 by Joseph Aspdin, a British chap, probably in his shed. Both are completely different. Both are very good at what they do, but they are completely different. And unfortunately, there are too many occasions now where we're seeing cement introduced into old historic buildings, which then has the possibility of causing long-term failure. And I'll show you some examples of that, including one worked example of a house I worked on a few years ago now. But you can see the logical process that someone went through to try and fix a damp issue, and all the time they were just making it worse and worse and worse. That is quite an interesting one. And I'm particularly happy I found some photos for it. No video, but I'll come back to that as well. Okay, so lime. Lime is lazy. Lime is calcium carbonate, CaCO3. If you drive past a farmer's field, you see a big pile of chalk. That is basically lime in a pure form. Here down in southeast Kent, we are, what are we? We're about 14 feet, 15 feet of clay over chalk subbase. Lots of areas of Kent are clay over chalk, and that is our pure limestone. It's made from burning that pure limestone to form calcium oxide, also known as quicklime. And when it's used as a building material, it sets with what we call a carbon reaction, so it's an air set. So the particles of lime that's in your mortar mix reacts with pulls in carbon dioxide from the air and causes that to help it set. So what it does, let me just explain this slightly, is if we've got a building and we've got lots of sand particles, because we're making mortar, and we've got all our sand, the lime sits in between the sand, reacts with the air, sets and forms what will eventually be maybe a mortar bed joint or so. So that gives you the finished result of what's going to be used to build your walls, or potentially sometimes as limecrete to form ground floors and stuff like that. So it's fairly straightforward, very good product, and like I say, used for thousands of years. Cement is a complex binder. It consists of four main parts. I'm going to have to read these off a list. Tricalcium silicate, dicalcium silicate, tricalcium aluminate, and tetracalcium aluminoferrite. I've tried getting my head around the chemical formula for that, but no, I'm not a material scientist, so that's not for me. So when these combine, this is completely different. It causes a chemical reaction. So it's a chemical set. So the cement particles react with the water to crystallize. So if we to understand this, if we perhaps consider mixing different gases to form a liquid, if we were to pluck out a hydrogen gas particle and another hydrogen gas particle and an oxygen gas particle, and we mix them together, we've no longer got gas, we've got a liquid, we've got water, we've got a molecule of water, H2O. And everyone's seen that H, 2 parts hydrogen to 1 part oxygen, is our water chemical formula. And I think most people are probably aware of that as perhaps one of the most basic chemical reactions that there is available. So going back to what we had earlier, if we've got particles of sand in a mortar mix, similar to concrete, but let's just consider mortar for the moment, and we introduce cement into that, this is our mix as it's gone into our concrete mixer, then we add in water, got blue, so water surrounds each of the cement particles, but then something special happens and it reacts. Let's go on to purple. So each one of these cement particles will then crystallize, and it will kind of crystallize around the sand particles. So that then forms that on that side forms our set mortar, or if we're using aggregates as well, our set concrete. This is irreversible. Once this set happens, you can't undo it. Whereas with a lime set, that is completely undoable. If there are any trainee bricklayers watching, or people that have gone through college as a bricklayer, they've had a thing called a pan mixer. So rather than using cement and destroying their work at the end of every day or the end of every week, we use lime in colleges. So what they do is they use their 1 and 4, 1 and 5 mixed lime mortar, build the wall. When it's done, take the wall down, scrape all the hard set mortar, bung it in a thing called a pan mixer. It recrushes it, pops some water in, remixes it. You can use it again and again and again. And I'll come back to that on the example that I'll show you later. That is how wonderful lime is. I've heard it said that lime can cure itself, it can repair cracks, and that is where moisture vapor transfer through a hairline crack in lime can rehydrate the lime mortar mix and causing it effectively to wetten up and reseal itself. So really, really good stuff. Where it becomes an issue is when people use cement on older buildings. Now, come to that in a second. If we were building a new building, quite often we might have a 1 to 5 cement sand mixture required by the designer. The builders on site might pop in some plasticizer, or they might add in 1 or half a part of lime. So you might be 1 part cement, half part lime, and then 5 parts sand. And that's to create workability. The lime does nothing to the actual mixture at the end of the day. And because it's a chemical set like we just showed there, this is how cement works. When we come to older historic buildings, and let's consider an historic building as something with a solid wall, we are starting to get into trouble if we want to introduce cement. So let's do a vertical section for a wall. So that's outside, that's inside. And then we have our mortar bed joints. Now, very, very common, a brick going the whole way across the wall. And then if it's a Flemish bond, the brick course above will actually have 2 bricks going the other way. And then 1 brick going that way, and then 2 bricks going the other way. So that brick would be there with a mortar joint, and then that one would be there with a mortar joint. And then it'd be there. So I've done another video on how walls work, stuff like that. So rain hits the outside of our wall, and this member is all lime. This is a lime mortar mix. It's been there for years and years and years, and the rainwater soaks the outer half to a third or so of the wall on a day like today. Now at the weekend, what was the weekend? It was, I don't know, 15th, 16th of September, something like that. Lovely weather, last nice few days of the year probably. When we get days like that, our water moisture evaporates out of the brick joints. This is called moisture vapor transfer, and it's calculated as vapor resistance. And the formula for that is mega Newton seconds per gram. That is how we calculate moisture vapor resistance for a material. So the lower the figure, the poorer it is. So I'm assuming on the basis of that, that polythene would have a figure of something like 0, whereas a more lime mortar pointing might have a figure of 5 or 6 or so. So that all works well. Now these joints are what we call sacrificial. So over the period of 20, 30, 40 years or so, these joints are going to gradually break down and fail, and we need to repoint it. A reason for that is during the winter months, we've got concentration of moisture trying to come out the joints. It will freeze, expand, and pop the joints off. Now that's happens. That's life. You know, there's nothing we can do about that. From time to time in the winter, the water in the brickwork is gonna freeze. Now, where we have issues is when it's repointed with a cement mortar pointing. So go back to our wall. So someone comes along, repoints with a cement mortar pointing, sometimes does something hideous like you can see in this photo here, where it's completely proud of the wall, and this plug is very hard cement mortar pointing. Now, no one's told the rain this, no one's told the solid wall this, so our outside third to a half of the wall is still going to get saturated by the rainwater. Unfortunately, because this joint is now much harder than the brickwork and the lime mortar joints behind it, no moisture vapor transfer can happen out of there. So instead it comes out the face of the brick. Now for, I don't know, 11.5 months of the year, that's probably not going to be a problem. But the trouble we have is when it does freeze, these outside temperatures drop below 0 or lower, we've now got a concentration of moisture in the face of the brickwork. So all the moisture in here is going to freeze. And we all know that when moisture freezes, it expands, and therefore we can get spalling of the brickwork occurring. Now, if you look in this photo here, this is quite advanced brick spalling. This is about a wall I took a photo of a few years ago. It doesn't really matter. But what we can see is the hard cement pointing where it's actually failed in parts, and behind it you can see the soft lime mortar pointing. This has caused the brick faces to freeze in the colder months, expand and spall. And in this property that I surveyed only last week, early September 23, we can see that the property is being repointed here in a cement mortar pointing, and in this photo here we can see that it started to cause the bricks to spall already. So the only option for this is to take it all off and start again. Okay, so a couple of years ago I was asked to help out with a property. Now again, vertical extension through the wall. This property had solid brick external walls, probably Flemish bond, can't honestly remember, doesn't really matter if it's Flemish bond, English bond, sometimes even English garden wall bond or Flemish garden wall bond in a property, but Flemish bond is by far the most common. If you're not seeing our other video, if we was to do a view of the front of the wall, and these are our bed joints, Flemish bond is essentially a header, a stretcher, a header, a stretcher, and then even below that would have a header, stretcher, header, stretcher, header, stretcher, and then that one repeats the course above. So on every other course you've got stretcher, header, stretcher, header, stretcher, header, and then it's the same but moved across so that the centre line of that brick is the centre line of the brick below. Flemish bond, really common, you'll see it in virtually every house. So this property, the front face, I think it faces southwest or so it's absolutely prime for prevailing wind to hit the front of the property. This is outside, this is inside. So you can see on this first photo here, this is what part of the front of the property looked like. A bit tatty, needed a bit of work. And inside, we've got this lovely cement plaster that's been applied to the inside of the property. Now, if we then look in these photos here of the render to the front of the property, you can see there are a number of cracks. So this will allow water to get into the wall, but because it's cement render, it's moisture vapor impermeable, water can't escape out of the render anymore. So it can only go one way, which is into the property. So we then look into the property. We had a big area of blown plaster on one of the front walls. We can see there's a cement render put on the wall, which has blown, but behind that is a bitumen coating. So when this wall started out life, let's go back to my little sketch. When this wall started out life, 1800, whenever it was built. So we've got our solid brick external wall, and we've got our lime mortar inside. Now, as we just said with that other example, over a period of time, these joints fail. What I suspect on this house from our general investigations that we did is that these would have been repointed using cement, as we said previously. And because water can't evaporate out the face of that anymore, the brick faces start to spall. The other issue is, because of the face of the wall is less moisture vapor permeable, more moisture comes through to the inside of the property. So what I suspect has happened here is they've repointed and the issues continued. So what they've then done is they then put a cement render on the front of the building, and this is cement, and thinking that'll stop it, that'll stop any rainwater getting in. Well, what it does, wherever you've got little cracks, hairline cracks in the render, or if you've got a window sill up there, you'll get water coming around the sides of that. Water can still get into the wall construction, but not only have you then got this mortar pointing here, doesn't matter if you haven't, that could be lime, it doesn't matter, but because you've got this impervious coating on the outside, no moisture vapor can now get out there because it's formed a barrier. So more moisture now comes into the wall. So what they've then done is they then put this black bitumen coating on the wall on the inside of the property and rendered over it with a cement sand render. So all they've essentially done in trying to do this, they've done 1 wrong, 2 wrong, 3 wrongs, 4 wrongs, all trying to correct what all they need to do first time around was repoint in lime mortar. So this whole wall is now absolutely saturated. And what we did is, because this area was blown, we took off quite a big area of plaster on the inside of the wall. And within days, we could start to see all of the joints, in the brickwork. The moisture built up so much, it pushed the bitumen coating off the joints. So you could see like a whole wall built where everywhere was black was a brick and everywhere was a joint was the mortar colour. So really good example of how not to repair a wall. So quite often asked, how can you tell if it's lime or cement when it's an existing wall? Well, sometimes you'll see the little bits of lime in it. That doesn't mean to say cement hasn't been added as a binder as well. And then you can get some, I think, hydraulic limes and stuff that set quite firm as well. So there is a little test we can do. You do need a little sample of the mortar or the render that you're testing, but I'll show you the test. So this is a piece of render that's been taken actually off the side wall of my house where we've been doing some general works. Nothing special, just a bit of render that we know to be cement render. And taken out of a fire damaged, very old property is a lump of lime render. And we can just about see in there, we've got horsehair, and then you can see the lime finished plaster on the inside. So what we can do, because it's a very basic test, but it's quite a good one to learn, is if we use some normal vinegar and we pop our cement into the vinegar, absolutely nothing. Got some air bubbles attached to it, but other than that, absolutely nothing. And that's because it's just cement and sand, there's nothing to it. If we now consider our piece of lime render, or what we perceive to be lime render, at this stage we don't know. Now our vinegar is very acidic, but our lime, if it is lime, will be alkaline. So if we pop that in, we can see the fizzing occurring, and this is because of the acid of the vinegar reacting with the alkali of the lime. So a basic test, but a good one to know. So I hope you found that interesting or a bit of use. It may be a bit basic for some, but we all learn something for the first time. The main thing I'd like to get over from this video is never add cement to mortar, to a lime mortar, if you're doing work to an old building. An old building, for it to perform well, should be completely devoid of any cement. That's just not required. All too often, as surveyors will specify a job, might specify it as a particular kind of lime mortar, get to site, see a bag of cement. What's this for? Oh, I added a bit of cement in as an extra binder. Now you just completely ruined everything that we're trying to achieve, and we might need to be taking work down then to have it rebuilt. So I do hope you found it interesting. If you wouldn't mind awfully subscribing and liking the video, that would be great. And if there's any questions, please pop them in the comments below. We'll either answer the questions as an answer or do another video on them as we have done before. So thank you for getting this far, and thank you for watching.